All right, so this is going to go over the vector review. So circle all of the following that are vector quantities. So in order to be a vector has to have direction. Okay, so that means positive and negative matter, north and south matter. So we're going to go through here. Speed is scalar. Speed uses distance. It doesn't care about direction, so that's a no-go. Temperature definitely does not need direction. Displacement does care about where you are versus where you ended, so that is a vector. Distance doesn't care. You add it all up. There is no negative. Okay, so it's scalar. So velocity, since velocity uses displacement over time, velocity has to be a vector. Force, which we'll cover more and more later on. Okay, force is directional, meaning you can have a positive force, you can have a negative force, so that is vector as well. Mass doesn't have a direction, so no go. Energy doesn't have a direction, it's just energy. Acceleration, that can be positive, it can be negative, so think about gravity there. Okay, so that is a vector. Time doesn't need direction. So that's just the big thing, is knowing that vector is something that has direction. 2, a boat travels at 13 kilometers per hour at 74 degrees south of west. Okay, so we're just going to go ahead and draw this out before we answer anything. We know we're going to be in our southwest quadrant, so I'm just going to draw an arrow going down here. Okay, south of west, so since that last letter is W, that means it's got to be touching west. Okay, so our angle is 74 degrees. Okay, and our hypotenuse is going to be that 13 kilometers per hour. Okay, so anytime I give you a value and the angle, that value is the hypotenuse. So A, it says what is the south and west components? So that means we're going to have to break this down into X and Y. So again, you can label it whatever you want to, as long as you can tell me which one's west and which one's south. Okay, so part A, we're going to break it down. So if I want to find my opposite, which is Y, okay, the only function that uses opposite and hypotenuse is sine. So sine of my angle is 74 degrees. Okay, so sine of 74 equals my hypotenuse, which is my opposite, which is Y, over your hypotenuse, which is 13. So what I'm going to do is I'm going to multiply both sides by 13. Just make sure you are in degree mode. Okay, so that's going to give us 12.50 kilometers per hour, and that is going south. Okay, so it just helps kind of keep that direction there so you can see it. Okay, then we're going to find our adjacent, so that's our x. So we're going to use cosine to find our adjacent. So cosine of 74 equals x over 13. So multiply those both sides, and you should get an x velocity of 3.58 kilometers per hour, and that is going to be going west. Okay, so there are your components right there. Part B, if the boat traveled 56.25 kilometers south, how long did it take? So remember we talked about, if we're not doing SOHCAHTOA or Pythagorean theorem, we are doing the whole V equals D over T. So velocity, displacement, and time. Okay, so my displacement, they told me, was 56.25 kilometers. Now it is going south, so that's a key thing there. How long did it take? So we're looking for time. So the reason I circled that south is because I'm purely asking about going south. So you need to use the velocity that is only going south, and that is going to be that 12.50. So 12.50 is your velocity. So we're going to do V equals D over T. So 12.50 equals 56.25 over T. So I'm going to switch the T and the 12.50. Okay, if you want to, I can draw this circle right here, the whole VDT trick. So V equals D over T. So if you're looking for T, just cover it up. That means you're going to do displacement divided by velocity. Okay, so 56.25 divided by 12.50, and you're going to get a time of 4.5 hours. Just be careful with this. You are in hours. Okay, I know sometimes you can get into autopilot with meters per second, so it is going to be hours this time. Okay, C, how far did the boat travel west during that time? So I'm going to set up my V, D, and T. So I'm looking for how far did it go west, so I'm looking for displacement. I'm talking about going west, so I'm going to use the velocity that goes west. That's the 3.58. And our time we just found was 4.5 hours. Okay, so we're going to set it up. So 3.58 equals d over 4.5. So you're going to multiply both sides by 4.5. And we're going to get a displacement of 16.11 kilometers. And that's going west. So there's your answers for that one. 3, what is the boat's total displacement in 45 minutes for the previous question? So total displacement means I want to find how far did that hypotenuse actually go. Okay, so we're going to do V, D, and T. Okay, so velocity is going to be the 13 kilometers per hour now. Okay, displacement is what we're looking for. And I gave you time, just be careful with this. It's in 45 minutes, and your velocity is in hours. So if you do this real quick, you just take 45 minutes and divide it by 60. That'll convert you to hours, so that's 0.75 hours. And now you're good. So V equals D over T, so 13 equals D over 0.75. So our displacement is going to come out to be 9.75 kilometers. And we're going to throw that direction on. If we're talking about the hypotenuse, we're just going to throw that angle on there, 74 degrees south of west. Okay, so there's your answer there. Okay, so now what we're going to do is we're going to take a look at just simple trig functions, kind of figure out what we're going to use. So I'm going to draw a triangle down here. So we're going to draw a right triangle. Okay, if given an angle and a hypotenuse, so that means this angle could be right here. I'm given the hypotenuse here. What trig function could be used to find the adjacent side of the triangle? So that means you were looking for right here. Okay, the one that's trig function that uses adjacent and hypotenuse, that is going to be your cosine. Okay, now if I'm given an angle and the opposite side, so now I'm given the opposite side. Let me clear this up real quick. Oops, let me fix that. So fix my triangle. So I'm given the opposite side. Okay, I'm given an angle on the opposite side. What trigonometry function would be used to find the hypotenuse? So that's what you're looking for. So which trig function uses hypotenuse and opposite? That is going to be sine. Okay, so now what we're going to do is, I'm going to erase this real quick. And we're going to go back to number 6. If given the opposite, so I'm given the opposite and the adjacent, what trigonometry function could be used to find the angle? So I'm looking for this angle right here. Okay, so the only one that uses opposite and adjacent is going to be tangent. So this is just more practice of knowing when to use cosine, sine, or tangent. Okay, so moving on to the next page. After walking 11 kilometers due east, a hiker then walks 11 kilometers due north. The total time of the hike was 4 hours. What is the total distance walked by the hiker? So that distance, remember, all you got to do is just add it all up. Okay, so 11 plus 11 is going to give you a total distance of 22 kilometers. You do not need direction. That's it. Now, what is the displacement of it? Okay, so we're going to walk 11 east. Okay, so I'm going to go east at 11. And then I'm going to go north from there at 11. Okay, displacement means I want to know where did I end versus where did I start. That means I'm looking for the hypotenuse. And direction means I'm looking for the angle. So if I know two sides of a right triangle, all I got to do is Pythagorean theorem. So x equals the square root of 11 squared plus 11 squared. Okay, so don't forget to do this square root at the end. Okay, so your hypotenuse is going to come out to be 15.56 kilometers. Okay, so that's your magnitude. Now we need to find our direction. Okay, I was given my opposite. I was given my adjacent. Okay, so the only function that uses opposite and adjacent is that inverse tangent. So tangent of your angle, which is, we don't know, equals opposite over adjacent. So 11 over 11. So we're going to bring that tangent over. Okay, so we're going to do inverse tangent. So the only time you're ever going to use inverse is if you need to find an angle. If you already have it, you're never going to use it. Okay, so just kind of keep that in mind. Okay, so when I bring that tangent over, it becomes inverse tangent of 11 over 11. Make sure you're in degree mode. Okay, and you're going to come out to be 45 degrees. Now, my direction, I'm touching the east line, so that has to be my last letter. So that's going to be north of east. Now, you could have gone the other direction if you want to. You could have gone north first and then east. You'd have gotten the exact same hypotenuse. In this case, you would have gotten the exact same angle because it's 45 degrees. It just would have been east of north. Okay, and then if you ever feel like this video is going too fast and stuff, you can pause it, work on things, rewind it what you need to. I'm trying to make it not too long, so hopefully that kind of helps out. What is the average speed of the hiker? So remember, speed is distance over time. Okay, so distance, we already found that was 22. My time, it said it took 4 hours. Okay, so 22 divided by 4 is going to give you 5.5 kilometers per hour. Average velocity, so velocity, so that means I'm actually using the displacement now. Okay, I don't need to draw it again. Okay, so we're looking for velocity. Our displacement, we found that in part B. Okay, so we're going to take that 15.56 and we're going to bring it down here. Okay, so 15.56 kilometers. Okay, and your time was 4 hours. Okay, so V equals D over T, so velocity equals 15.56 divided by 4. And you're going to get a velocity of 3.89 kilometers per hour. Now, velocity is a vector, so we got to throw direction on there. So we're just going to keep our same angle, 45 degrees north of east. Number 8, a dog drags his toy in the yard. First, he drags it 12 meters to the east and then 16.5 meters to the south. So we're going to draw it 12.5 meters to the east. And then we're going to go straight from there, and we're going to go 16.5 meters south. So that means we're going to make this triangle right here. So it says, what is the resultant displacement? That just means hypotenuse. Okay, so we're going to find the magnitude and the direction. Okay, so we're going to do more practice there. So we're going to find our hypotenuse. So x is going to be the square root of a squared plus b squared. So 12.5 squared plus 16.5 squared. And you're going to get a resultant displacement of 20.70 meters. So there is your magnitude. We're going to find our angle now. So we're going to skip a step. So we know it's going to be inverse tangent because we're dealing with opposite and adjacent. Okay, so 16.5 is your opposite because it's opposite of the angle. And 12.5 is your adjacent because adjacent means next to the angle. Okay, so that x is always going to be the hypotenuse. The longest side is always the hypotenuse. So I'm going to put that in my calculator, and we're going to get 52.85 degrees. It is touching the east line, so that has to be the last letter. So we're going south of east. So there is your angle there. Moving on to the next one. This is more kind of conceptual stuff. A person is walking at 2 meters per second on a moving walkway that has a velocity of 3 meters per second. What is the velocity of the person as witnessed by an observer off to the side? If the person is walking in the same direction as the walkway's motion. So that means I have a person walking, doesn't matter which way you point it. Someone's walking 2 meters per second this way. They get on the conveyor belt and it's going 3 meters per second in the same direction. So think about this in your airport is when you see people get on those, it looks like they're walking faster because you're adding those velocities. So we're going to do 2 plus 3 means we're going to have a velocity of 5 meters per second in that same direction. Now, B is the same pretty much problem, but watch out for bolded words. I asked for opposite here. So what happens when that person is walking this way now at 2 meters per second, and the belt is still moving this way at 3 meters per second? So, person's not going to walk faster. They're actually going to walk slower because they're going against the motion. Okay, so we're going to do 3 minus 2. So it's going to look like they're going 1 meters per second, but you got to figure out which way are they going. Even though they're walking the other way, they're not overpowering that moving walkway, so it's still going 1 meters per second towards the right. What would the person's displacement be in 4 seconds in the previous question while walking against the direction of the walkway's motion? So, remember I said only equation we're using in here is V equals D over T. Okay, the velocity I found was 1. Displacement, okay, that is what we're looking for. and my time is 4 seconds. Okay, so V equals D over T, so 1 equals D over 4. So we're going to get a displacement of 4 meters. Now, that's still going to be 4 meters to the right, okay, because that is the way their velocity is going. You could have said east if you wanted to. You could have said west. Either way, doesn't matter. Number 11, what does it mean to say that motion is relative? Okay, that means it depends on where you're observing it from. So it depends on the observer. So that means you may see something different than I am because of where we are. So that is also in relation to your frame of reference. How you are comparing it to something else versus how someone else is comparing it to something else. 12, for two vectors to be independent, how do they need to be oriented to one another? They have to be perpendicular. That means that north and south do not affect east and west. Okay, now as soon as you start going into those, okay, so right now let's say if I'm running north, okay, if I have a south wind, that is going to slow me down. Okay, if I have a north wind, okay, going towards the north, okay, that's going to help speed me up. Okay, but if I have a side wind coming across, it could push me off track, but it's not going to help me or hurt me. Okay, so it's not going to affect anything going north and south. Okay, as soon as you start muddying those waters, as soon as you start slanting motion, like say all of a sudden now you've got wind coming at this way, then that kind of starts affecting each other. But if vectors are set up perpendicular to each other, they have that 90-degree angle, they're not going to affect each other. So now we're going to move on to the next problem. So it's going to be our boat problem. So if a motorboat travels at 8.5 meters per second to the south across a 110-meter wide river, the current in the water flowing east at 3.8 meters per second. What is the boat's resultant velocity? It would be the magnitude and direction. Okay, so it doesn't matter how you draw this. I'm just going to go south first. Okay, I'm going to use my boat's velocity, so that's going to be 8.5. And my river is going east at 3.8. Okay, so this is going to create my hypotenuse right there. Now, you could have gone east first and then south. It totally would have been fine. Your hypotenuse would have been the same. Your angle is going to be a little different, but I'll go ahead and write that answer whenever we get there, just in case you did that one. So I know two sides of a triangle, so we're going to do Pythagorean theorem. Okay, so we're going to do the square root of 8.5 squared plus 3.8 squared. Okay, so we're going to find that. So make sure you do that square root part at the end. I've seen people that kind of forget that. I think they get too hung up because they know what to do in the next step and they forget to do that square root. Okay, so you're going to get 9.31 meters per second. So that is your magnitude. Angle, so we're going to find the angle now. So if I ask for direction, you need angle and direction. So I'm looking for angle. I know my opposite. I know my adjacent. So we're going to do that inverse tangent. So opposite is 3.8 over your adjacent, which is 8.5. Okay, and you're going to get an angle of 24.09 degrees. I'm touching the south line and going east of it, so it's going to be east of south. So that is your angle if you did a triangle like mine. If you went east first and then south, your angle is going to be 65.91 degrees south of east. So these are called equivalent angles. Equivalent angles means they both add up to 90. They just have a different direction on them. So we have east of south versus south of east. But regardless, an equivalent angle means if you know one angle, the other one has to add up to 90 degrees. B, how long does it take to the boat to cross the river? So I'm talking about going across the river. So that is going this direction. Okay, so remember we said if we're not doing SOHCAHTOA or Pythagorean theorem, we're doing V, D, and T. So if I'm talking about going across the river, I'm going to use the velocity that goes across the river. Okay, I cannot use the resultant that I just found. I'm not going to use the river. I'm not going to use 3.8. I'm going to use the velocity of the boat because that is the only thing that's moving directly across the river. So 8.5 meters per second. I'm looking for time because it says how long does it take. And I know my distance across the river is 110 meters. Okay, so please be careful with this. It's not the math that's going to get you. It is if you use the right velocity or not. So if I'm talking about crossing the river, just make sure you use the velocity that's going across the river. Okay, so V equals D over T, so 8.5 equals 110 over T. Okay, you can switch these two. So it's going to be 110 divided by 8.5, and that is going to give you 12.94 seconds. Okay, moving on, part C, how far downstream is the push? So I'm talking about going downstream. Okay, so we're going to use the velocity that's going downstream. That is the river, so 3.8 meters per second. Okay, displacement, that's what it's asking for. When I say how far, you're looking for the distance. Time, since I found time up here, I can use 12.94 again. So V equals D over T, so 3.8 equals D over 12.94. So multiply both sides by 12.94, and you're going to get 49.17 meters downstream. D, what is the boat's overall displacement? That basically means I am just going to figure out, so if my hypotenuse of my triangle looks like this, I want to know what is this displacement right here. Okay, so we're going to use the velocity that goes in that direction. So now we actually get to use the velocity we found in part A. That is going to be the 9.31 meters per second. Displacement, that is what we're looking for. Time, still the same, 12.94 seconds. So V equals D over T, so 9.31 equals D over 12.94. So multiply both sides, and you're going to get a displacement of 120.47 meters. And we're going to throw direction on there, but we've already found it, so you don't need to do it again. Okay, so you're going to do 24.09 degrees east of south. Okay, part E. What direction would the boat need to travel to land exactly opposite the river on the other side? Okay, so what happens is now my boat, I want my boat to do this. I want it to go directly across, but I have to angle my boat upstream to be able to do that. So now my velocity of the boat is still the same. Okay, so it's still going to be 8.5 meters per second. Okay, the river is still staying the same. That's going to be 3.8. I just need to figure out what this angle is. So I have a hypotenuse. I have my opposite. So the only thing it uses opposite and hypotenuse is sine. Okay, well, in this case, yep, so I'm going to use my sine. Okay, so my angle is going to be inverse sine, because I need to find that, of opposite over hypotenuse. That is going to be 3.8 over 8.5. Okay, so in this case, my key had the wrong answer on here, so I'm not actually sure what this is. Okay, so I'll fix that key and I'll have it on there, but you should be typed it in, inverse sine 3.8 over 8.5. You should get an angle, and that is going to be, it's touching the south line and then going west of it. Okay, so that's going to be west of south. So my apologies for not having that on there. Okay, number 14, if the boat in the previous question turned and headed east or west, what would be the boat's maximum or minimum velocities? Okay, so that means if my boat decides to go with the flow at 8.5 and the river is going this way at 3.8, what would be the resultant velocity of that? Okay, so that's going to be my maximum velocity. That's going to be 8.5 plus 3.8, and that's going to be 12.3 meters per second east. Okay, now if I decided to go against it, so now the boat is going 8.5 west and the river is still going 3.8 east, I'm going to find that gap, so 8.5 minus 3.8, and you're going to get 4.7 meters per second, and that is going west. Okay, let me fix that real quick. So that is going west. So that is your maximum and minimum velocities right there. And that is going to end the review.